right, we are back. This is Math 200. We're looking at Chapter 7, the note packet, and this is 7.3. Let's take a quick look. That is page 8 on the note packet. So complex rational fractions. All right, so what that means is a fraction over a fraction. And there are two ways to attack the problem. This way is not the best way. This way is a little harder, I personally think. And I'll show you another technique that's a little easier. But this way, what they want you to do is pretend like this is its own problem, just the numerator, and you find the common denominator between 2 and 1, that's 2. So we want the 2's on the bottom, so we multiply this one, both top and bottom, by 2, and 4 halves, that stays x over 2. Now you do the same thing with this, again, common denominator is 2. You have to multiply that by 2 and that by 2, we get 4 halves again, and x, and now what you can do is say x plus 4 all over 2 divided by x minus 4 all over 2. And now what we can do is write it as a divided by problem. And we never divide fractions. Remember, we multiply by the reciprocal. So it's x plus 4 over 2 times 2 over x minus 4. Those 2's cancel off, and you end up with x plus 4 over x minus 4. All right. And so that's what we have for that. Not the easiest way to do it. I'm going to show you, I think, a much easier way. So on the second number 1 here, we've got 1 over y squared plus 2 over 3 over 1 over y minus 5 over 6. And so what you do is you find the LCD between y squared and 3 and y and 6. So y squared is just y times y, 3 is just 3, y is just y, 6 is 2 times 3. And so now we're looking for matches. So there's a match there, y. There's a match there, 3. There's a match, no, not a match, that's a leftovers, 2. And that's a leftover y. So you take all the matches and all the leftovers, the LCD turns out to be 6y squared. Now what you do is you multiply the numerator of each one of these terms by 6y squared. So if you think about what's happening there, you're multiplying the top of the fraction by 6y squared and the bottom of the fraction by 6y squared. So just like how I did this 2 times 2 on that one individual fraction, I'm doing that to the whole numerator and the whole denominator and distributing it. So that's what's happening. That's why it's there, 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 and there. I think in general, it's easier to look at if you just attach it to the numerator of each one. So now think about what we did. We found the lowest common denominator. That means this will go into it, this will go into it, that will go into it, and that will go into it. And we multiplied it on the top. So we end up with 6y squared over y squared. We end up with 12y squared over 3. We end up with 6y squared over y. And we end up with 30y squared over 6. So think about what's going to happen. The y squareds are going to cancel. And I'm going to get just 6. 3 is going to go into 12 4 times. That'll be plus 4y squared. One of the y's will cancel off, so 6y. And 6 goes into 35 times, so minus 5y squared. And again, you could factor it. I think that's as good as it gets. If you wanted to, you could factor out the 2 on the top, 3 plus 2y squared, and y on the bottom, 6 minus 5y, and it's just exactly the same. So this would be okay, or this would be okay. If you want it in factored form, nothing will cancel. The 2 and the y won't cancel, and the binomials are completely different. So either one is fine. All right, let's look at another one of those. And this one will be a little easier to find the LCD. That one was a little complicated, but lowest common denominator. So let's look at this one. It's x plus 1 over y all over x over y plus 2. Well, that's 2 over 1. The LCD here is y. So this gets a y, this gets a y, and this gets a y. So now look, here, those y's just cancel. And you've got your numerator, x plus 1. These y's cancel. You got x plus 2y. And that's it. That's what I mean. This is usually pretty easy to do it. A lot easier than the first technique that I showed you. All right. So let's look at one more problem, and then we'll go on to 7-4. So we have x to the negative 2, y to the negative 2, or 5x to the negative 1, plus 2 over y to the negative 1. So now, this is actually 1 over x squared times 1 over y squared over 5 over x plus 2 over y. And so again, if we look at the LCD here, x squared, y squared, and 5 over x plus 2 over y. The LCD, right, there's 2 x's, there's 2 y's. So if we write that one out, it is x, x, y, y. X is just x, y is just y. So you take what they have in common. They both have an x, they both have a y, but then you take the leftovers and you end up with x squared, y squared. So that's my LCD, x squared, y squared. I'm going to multiply this by x squared, y squared, this by x squared, y squared, this by x squared, y squared. And let's see what happens. Everything cancels there, I get 1. Here, 5xy squared, here, 2x squared y. And again, if you want to, you could factor out an x, y, but it's not going to change. Nothing will cancel with the 1. So you can just leave it like that. That's fine. And that is it for 7.3.